As we progress into just being able to solve things using a graph, solving the way that we had done earlier problems, we can also do them using a graph. So we're doing more inequalities, and this time it's not just x values that we care about, we want the x and the y values. So just like we did in the previous section, we're going to see which of the following points are in the solution set. And this time what you have to do, instead of just substituting one variable, you have to substitute both variables. So where there's a y in that inequality, put a 4, and where there's an x, put the 1. And is it true, and just evaluate, is it true that 4 is greater than 1 squared minus 4? Well, 1 minus 4 is negative 3. Yes. So I'm going to circle the solution ones. Because if we look at the next one, I'm not going to write as much out, but you're plugging in 0 for y, because that's the y coordinate, and then 2 for x. Well, 2 squared is 4 minus 4 is 0. Is 0 greater than 0? That answer is no. So I'm not going to circle that one because it's not correct. And as we look at the next one, just slightly different color, or a lot different color, but plug in 1. Is 1 greater than, well, be careful, because when you square negative 2, it's a positive 4, and 4 minus 4 is 0, and this is another one that works. So yes, I'm circling that one. Now, if I asked you, so in this problem, the points on the parabola y equals x squared minus 4 are not, so no, they're not in the solution set because of this equal, and this was just a greater than. Equal to is not included in the statement of greater than. Now, if it were greater than or equal to, then it would be included, but it's not. So the way we distinguish it is we put a dashed line, or dotted, depending on your teacher or textbook. We put a dashed line to indicate that. You may have learned that in Algebra 1. So if I asked you to graph this problem, what I would just expect students to know is, instead of going through all the work, because y equals x squared is a graph that typically looks like this, but that minus 4 is going to take each one of those points and shift it down 1, 2, 3, 4. And then it looks very similar. And then go on from there. And we can verify that this is correct with the graphing calculator. And as I mentioned, we're going to do a dashed curve instead of a solid curve. And it doesn't really matter how you put your dashes on there, just indicate that you have that kind of behavior. And what you could do is you could pick out points that work. Like, remember earlier we had 1, 4 worked. 4. 2, 0 did not work, but negative 2, 1 did work. And what happens is the region where the points work is where we shade. I don't know if you did this before, and they want us to call it region Q. But usually we just shade in that region. So a big piece of advice, because you know how in the previous section I said just to plug in 0 and see if it works. I usually tell students to try the easiest point possible, like 0, 0, and see if it works. And if you did that, well, 0 is greater than 0 squared minus 4. So yeah, you want to shade that region. We can also do this for a set of inequalities, like a problem like this. Oops, that's kind of wonky there, but that's okay. So if I were to ask you, maybe I'll do this one in like a pink color. If I were to ask you to graph y equals negative x squared plus 6, and you go through our process on graphing, I'm going to just give you the hint on this one that it's shifted up 6. So instead of being at the origin, but then this is telling me that I have a downwards u. So it's instead of opening up, it's opening downwards. 1, 2, 3, 4, 5, 6. And then we're going to go down. And then 1, 2, 3. I don't know if you've ever seen these shortcuts before, like you go down by 1, then by 3, and then down by 1, 2, 3, 4, 5. But this could be helpful. Because it's just a less than, we're going to put a dashed line in there. And if I were trying to decide which region works, I would try 0, 0. Is it true that 0 is less than 6 minus 0 squared? Well, 6 minus 0 squared is 6. So yeah, I would have to shade that region. And sometimes I'll even shade with a highlighter because it shows up lightly on here. But I don't know what the other graph looks like yet. So I don't know quite exactly, but I need to shade all of that inside. And what I'm really concerned about is where they overlap. So the other one's a little bit trickier to graph, but you may remember our rules of negative b over 2a. So if you remember a, b, c, then if we were doing negative b, it's going to be positive 4 over 2 times 1, which is positive 2. So my vertex is going to be located at x equals 2. Well, if I plug it back into the original problem, 2 squared is 4, minus 8 is negative 4, plus 3 is negative 1. So 2, negative 1 would be the bottom of my vertex. I'm just going to put a V there. And then this graph is also having that same behavior of up, and then up by 3, and then up by 5, 1, 2, 3, 4, like right at the end of the graph. But this time, it's a solid line because it's or equal to. So that's telling me it's a solid line. Man, I am struggling to draw this one very well. And I would also try 0, 0. Because if I tried 0, 0 on this one, I would have 0 is greater than or equal to 0 minus 4 times 0 is 0 plus 3. Is 0 greater than or equal to 3? No. So that one should also be shaded not including 0, 0. So if I get a different color highlighter, it would be on this side where 0, 0 is not located. And where those two regions overlap is right in here. So if I were trying to pick a point that it works on, there's a lot of points in here, but maybe just try something as simple as like the ordered pair 1, I don't know, 2. If I went right 1 up 2, it looks like that point works for both regions where my gray highlighter and my yellow highlighter intersect. And you can double check that they work for both. 2 is less than 6 minus 1. 2 is less than 5, that's right. And then 2 is greater than or equal to 1 minus 4 is negative 3 plus 3 is 0. So yeah, that worked as well. So here's another one, but this one's a little bit trickier because they just wrote it as one statement. So just a reminder, this is the same thing as y is greater than x squared minus 4. So I'm just looking at, maybe I'll highlight it for you. That's just this left piece. And I flipped it around because it's read as this thing is less than y, so y is greater than. And then the other equation is just y is less than or equal to 5. I'm going to start with that one, actually. So I'm going to put a little star next to it. Because that's just a horizontal line. It's going to be solid because it's or equal to. And less than means that I want to shade below that. So I don't want any y values that go past that line. Now if I look at this other one, if you follow my rules I've been discussing, it's shifted down 4 from the origin, and it's an upwards U, so it goes up by 1, and then goes up by 3, and then goes up by 5. But this time, it's a dashed curve. Because it's or equal to. And if I tried to plug in, say, 0, 0, Well, this time, is it true that 0 is greater than 0 squared minus 4? Yeah, 0 is greater than negative 4. So I want to shade in the region that includes 0, 0, but I need to be below that horizontal line. That's it. So this one is just going backwards. I'm giving you the equation, but now you have to come up with the one that works. So the first thing that I notice is all of these equations are the same, except the inequality is different for each. So I'm seeing the dashed right away. So since I'm seeing the dash, I'm going to cross off the equal to, because these ones should be solid if it's equal to. And then the next thing I would do is just try 0, 0 and see if it works. So if I plug in 0 for y and 0 for x, is it true that 0 is less than negative 3? And if it's yes, that's your answer. If it's not, it's wrong. It's wrong, because 0 is greater than negative 3. That's all I would do on that one. Just sort of guess and check. And then here's one more, and I'm missing a graph here, but it's the arch of a bridge. The way I'm thinking of that is kind of like this. And the way I'm, and hold on a second. Yeah, I was thinking of this a little bit differently, but this is the right thing I was thinking of. And I guess what I shouldn't just assume that this is the right thing, but if you were to just look at y is less than or equal to 300, maybe I should put an x and y axis on here. So an x-axis and a y-axis. If I had this labeled properly, somewhere up here would be 300, and using that same color, y is less than or equal to 300, it's just a horizontal line like this. So that's my horizontal line, y equals 300, but being less than would mean that we need to be below that curve. Now this other piece, this piece right here, is just saying that x is bigger than 0, but x is also smaller than 600. So if I'm looking at this, if we're bigger than x equals 0 is just on the y-axis, so it's to the right of that piece. And we'll find out here shortly that x equals 600 is all the way over here, and being less than is going to be on this side of it. Over here is x equals 0. So the only thing left to do, and I kind of ruined the answer for you already, and I don't know if that upsets you, but this other piece of y is greater than or equal to, because it's written as less than, so if I flip it around, I would actually rewrite it as negative x squared over 360, and then plus 600 over 360x. And the reason why I would do it that way is because then I can use my x equals negative b over 2a formula. And my b value is that 600 over 360 over my a, which is double the negative 1 over 360. And you probably don't know this, but here's a trick with math, is when you have the same denominator with two fractions, they actually cancel each other out. And two negatives will cancel as well, which is how I, like I said, kind of ruined it for you, that the vertex is going to happen. So that V, right, B right there, is at 300, and that's how I knew that this was going to be 0, 0. And I would use a calculator to figure out what that y value would be. So I need to go to a calculator, type it in. So 600 I'm going to pause the video and then bring this answer up. There we go. I know it's going to take me a while to type it, but that told me that my vertex, by plugging in my 300s for x's, goes up to 250. And because we want y is greater than, just for the sake of time, this is going to be above that curve, and we have our final answer. And we're ready for the homework now.